Paulo Shakarian, CEO and co-founder of Cyrecon. Thanks for joining me today. So in today's video, we're going to talk about two of the most common measurements used to evaluate a machine learning algorithm, and two that I personally find to have a high degree of practical relevance, especially in the domain of cybersecurity. And they are precision and recall. So first, how are they defined? So precision is very simple. Precision is the number of results produced by the algorithm that were correct divided by the total number of results produced by the algorithm. So I'll give you an example. It could be the number of, say, SOC alerts that were really malicious events produced by, an algorithm that flags SOC alerts, divided by the number of alerts that the algorithm said were malicious, whether or not they were actually malicious. So if you said the precision was 0.9, that would mean that 9 out of 10 alerts that this algorithm said were malicious actually were. So the second measurement goes to recall. And recall deals with taking the number of correct events by the algorithm, so the same numerator as with precision, but now you're dividing it by the total number of items of that type. So going back to our example of SOC alerts, the numerator for this would be, let's say, 9 alerts that the algorithm correctly identified as malicious. But then the total number of malicious events that it could have predicted, maybe it was, say, 20. So in this case, you're looking at a recall of 0.45. So the algorithm in this case, it had a 90% precision. So most of what it was saying was right. But on the other hand, it wasn't catching all of the events. Now the question is that useful or not to you? Well, it's really going to depend on the type of events that the algorithm was catching. If it was identifying things that you had no other tool in your arsenal to catch, then that's really great. It's accurately finding stuff you had no other way of catching, even though it's not identifying everything that's bad. The bad things it is identifying were very hard to find otherwise. And so that's a case where high precision and low recall in cybersecurity could be really useful. Now, if you're relying on the solution to capture all of the events, or almost all of them, and that's how you've done your risk analysis, then in that case, a solution with those kind of numbers might not be the best one. In that case, if you're really relying on catching all or almost all of the events, you're probably going to have to go with something that has a little bit lower precision. And typically, as precision goes up, recall goes down, and vice versa. Now, are there ways to cheat on these numbers? Or maybe I shouldn't say cheat, maybe for a vendor to game those numbers a little bit. And the answer is absolutely. So what are kind of the common ways to game those numbers? Well, I could say precision is defined as the number of alerts correctly identified. So I correctly identified 9 that were malicious and the algorithm said were malicious. And then I identified an additional 50,000 that my algorithm said were not malicious that were actually not malicious. So that number is now divided by my total of, maybe it was like 50,200 or something like that. And I have suddenly sky-high precision results because it was able to see, an HTTP request to my internal web server or a connection to my regular database that I hit every day, was able to see that that was okay network traffic and didn't give an alert. And that's a very easy way to game the results. Same goes for recall as well. Because if I'm catching a lot of things that maybe you don't care about and sort of mixing it in with the important results, again, I could have artificially high numbers. So a way to check that is to ask really probing questions of the vendor. Is if they're talking about precision and recall, ask them how those are computed and differentiate between number of correct results versus number of correct with respect to something you care about, like malicious events. Another way to also game the results is look at the data upon which they evaluated that. First, is it real world data versus simulated? In many scientific papers, you might see the use of simulated data. And so that is the first red flag. Admittedly, I don't see this as much with vendors who try to push results. A second way to manipulate the data is artificially balance the classes. Now, there's something that many of you don't know, and I'll probably do a video on the topic of class imbalance a little later. But if I give you a data set where it's 50-50 down the middle between, say, malicious and non-malicious events or binaries or whatever you're trying to identify, it's much easier for a machine learning algorithm to figure out how to predict or identify the difference between the two. And that's called balanced classes. If I'm dealing with, say, 90 and 10 split, or maybe 98 and 2% split, which especially for things like malicious events or binaries is much more common, because let's face it, the vast amount of stuff that goes through your network is benign. That is much harder for a machine learning algorithm to deal with. And so many companies will, when they do this analysis of performance, they'll look to balance the classes, and they'll do that in the data that they use to provide their performance numbers on. I've even seen vendors that provided the balanced data results and then the imbalanced results as well. But they'll put the headline on the balanced results because that'll be very high, and then the imbalanced results, won't be so much. But the other thing is you should look at the results relative to, the fraction of events that had, that were malicious or not. And that is also will be very telling, but we'll cover that in a later video. So anyway, just to recap, precision and recall, these are two very well understood measurements in machine learning. And they also have very high degree of practical significance, especially in the domain of cybersecurity. Precision can be thought of as the fraction of results from an algorithm that were correct, while recall is the amount of things or the fraction of things that the algorithm identified. So hope you found this useful. Please stay tuned for more videos. Bye now.